All right, so I'm going to go over with you this worksheet, and then depending on if I can get my act together, I'm either going to embed some questions in here through Edpuzzle, or what I'll end up doing is I will be putting them into the test wizard, and I will have questions that we can go over for more practice. I'm going to apologize in advance because I just started my washing machine, and that's what you hear behind me, and it's really late. I have to run laundry, and I need to go over this at the same time. So you'll periodically hear my washing machine filling with water. So that's that. I'm going to go through this with you, and let's hammer this out to make sure we're on the same page. I'm going to we did this one number 2. We did number 4, and they were in the flip, the stream, but I'm going to do them really quick again. So cut the reaction in half. I'm going to add hydrogen, so I have more hydrogen, which means I'm going to produce more product, which means I'm going to consume the nitrogen in the process. This reaction would shift to the right. Nitrogen would go down. Hydrogen is my initial shift, and the amount of ammonia would increase. Start again, clean it up. Here we go. And should probably shrink this down. And here we go. Next one. If I add more ammonia, so more ammonia, I'm going to have more nitrogen. I'm going to have more hydrogen. I'm going to consume the energy in that process. So this would shift to the left. The amount of nitrogen would go up. The amount of hydrogen would go up. And I'm ignoring the K column completely. K is not energy. And my initial shift was the ammonia, so that's what I'm seeing there. Okay, clean. Clean, 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 clean. All right, next one. So, cut the reaction in half. I'm going to remove my nitrogen, so less nitrogen. Less product can be formed. I will have excess hydrogen lying around. This guy shifts to the left. That's my initial shift. I will have more hydrogen. I will have less ammonia. Clean. Clean, 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 clean. Right. And again. So I'm going to remove hydrogen in the story. Less hydrogen, less product, excess nitrogen that's laying around that's not being used. So this would shift to the left. I would have excess nitrogen. This is my initial shift. And I would have consumed the ammonia in that process. All right. Moving on. Cut. Okay, I'm going to take away ammonia, which means I have less of this stuff. Can't produce as much. I will have extra energy lying around that I'm not using. Shift to the right. Nitrogen drops. Hydrogen drops. That's my initial shift. Okay, so that's this first page. You can shoot me a text in the remind to let me know if you can't wrap your mind around where these shifts and these arrows are coming from. This is kind of what we did on the first stream of LeChatelier. This was the new material that we talked about last night. So the temperature, which means I need to grab this equation. So clean. Clean, 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 clean. Snip, snip. Let me snip this. And I'm going to bring this into this. Shrink this bad boy down. Boop. Okay. And I'm going to handle this the same exact way. Cut the reaction in half. I'm increasing temperature, and I'm going to shift on my energy term here. So this would increase. I can make more product, or this is actually more reactant, and I would consume the ammonia in that process. This would shift to the left. I would have more nitrogen, more hydrogen, less ammonia. I'm not doing K. Clean. Okay. And again, cut the reaction in half. If I drop the temperature, I cannot produce as much nitrogen. I cannot produce as much hydrogen. I'll have extra ammonia lying around. This would shift to the right. I would have less nitrogen, less hydrogen, excess ammonia. Okay, final set of shifts is a pressure shift. When I assess for pressure, I'm not going arrows. It's not going to work. I need to start counting the number of moles of gas. So there are 4 moles of gas on this side, and there are 2 moles of gas on this side, and then I need to ask myself, well, what is the shift? I'm increasing pressure. Is this ideal or not ideal? So I'm going to go down here because I added this little set of rules in here. If I increase the pressure, that's not ideal. Like goes against the vacation theory. According to the vacation theory, and I'm going to slap this in down here. According to the vacation theory, a gas is most ideal at high temperature and low pressure. Just going to drag this out. High temperatures and low pressures. If it is not ideal, that would be a low temperature and high pressure environment. I'm not interested in temperature. We don't handle temperature shifts this way. We don't, count the number of gas particles. So I'm not interested in temperature. Goodbye, temp. I am interested in this component. Ideal is low pressure. Not ideal is high pressure. So I'm increasing the pressure. The pressure is getting higher. Well, increasing pressure is not ideal. I favor the side with less gas. Well, that's this side. I am going to shift to this is left, this is right. Okay, shift to the right. And if it's increasing pressure, they all go up. Next one. If I decrease the pressure, well, that is pretty ideal. I am going to favor the side that has more gas, so that would be the left-hand side. And because I'm decreasing pressure, they all drop. This is the reason right here why you gotta go left versus right with the counting of moles, because the arrows do nothing for you in terms of pressure. The final thing I'm going to throw in here today, which is the last component of LeChatelier, and then we're all done, is the catalyst. And the idea here is you have a forward reaction, you have a reverse reaction. The energy is on the product side. So if I had to draw this, it would be going from high to low because it's exothermic. In order for you to activate this chemical reaction, you got to hit the hill. But when you add a catalyst, you provide an alternative pathway to activation. I'm going to go catalyst in purple. So when you add your catalyst, you make it easier to activate going forward, which would favor the forward reaction, but at the same time, you also make it easier to activate the reverse reaction. So when I add a catalyst, does it favor the forward? Yes. Does it favor the reverse? Yes. It favors both of them. In fact, it favors both of them equally because it makes it equally easier going forward and equally easier going backwards. You're just trimming off the top of the hill and you're subtracting, let's say it's, you're saving 20 joules. Well, you're saving 20 joules going forward, but you're also saving 20 joules going backwards. Whenever you add a catalyst, there's no shift. You're not shifting left, you're not shifting right. But that does not necessarily mean that you're not changing the equilibrium. You're not favoring one side or the other. You favor both sides equally. That's not how you spell equally. You favor both sides equally, which means that you are going to speed up the rate of the forward and the rate of the reverse in equal components. So you are going to favor the forward and reverse equally, which means you are going to speed up the rate of reaction for the forward and the reverse equally. So this is the last component today of what we need to talk about with LeChatelier and equilibrium. when you talk about a catalyst, there's no overall shift. You're not favoring one side or the other. You favor both sides equally. So if they ever ask you, it's not that there's no change. You're changing both rates forward and backward equally. And if I kind of had to draw that for you, it would kind of look like this is like homeostasis. And you're maintaining this balance. And then you throw a catalyst in here. Well, you're still going forward. You're still going backwards. But like you're changing the rate equally. And there's no overall change to the equilibrium because both of these are being affected in the same exact way. Do you see the difference? They're both being affected equally the same exact way. That's the concept. I'm trimming a little bit off the top, but both the forward and the reverse are affected the same exact way. Okay, I'm going to see if I can embed some end puzzles in here, which would allow you to do a little bit of practice. Otherwise, I'm going to just do it in the test wizard and figure out add puzzle another time. All right. I'm not streaming live tomorrow, which it's 11 o'clock tonight. So I just finished the last stream. I'm not streaming live. This is the audio component of whatever it is, that we're wrapping up tonight. You're working on the Poggle, you're working on those practice questions, and then I will set up a stream most likely for Friday again with a new idea that we're going to need to talk about. All right. I will talk to you all soon. Bye-bye.